can blur your background.
Hi guys, it's about to start in 1 minute. I guess. Why do I look like this? It's about to start in 1 minute, and I think it started. Oops, I'm late. I'll try to share my screen. This is my first rated Division 2 after so long, after 3 years or so, and I hope I'll get positive. I'll finally break my negative streak. So many negative ratings. I'll break the streak. I hope today. It's loading slow. So, do you guys think I'll get positive rating or I'll get another minus 150 and come back to specialist? Why is it just loading? Why is it not showing me the contest? Division 2 is red. My laptop is too slow these days. Somehow it's very, very slow. I'll try to be very quick today. Array coloring, max reordering, sorting name, D1, D2, E, per proof of vertex, medium permutation. We have too many problems here. How many can I solve? You have n cards arranged in a row. The ith card has an integer AI written on it. All integers are distinct. You must color each card either red or blue such that the following conditions are satisfied. Any two adjacent cards in a row have different colors. So it's either red, blue, red, blue, red, blue, or blue, red, blue. If you rearrange the cards so that the numbers on them are in increasing order, any two adjacent cards in the new row must also have different colors. Determine if such a coloring exists. So what does that mean? All of them are distinct, right? So you can just arbitrarily sort them. I'll just make them as pairs, okay, so that we can have color. I'll first color them, okay. So we have colored them. Now we will sort them. Now what should happen is, after sorting, if two colors are equal, we'll return wrong answer, okay. Because there's only a unique way to do that, right? Or other case is either 0 1. Instead of 0 1, you will do 1 0. But both of them are same, right? 0 1 or 1 0. Finally, we are just checking after sorting if they'll still be satisfied or not. So that should be fine. Yes, so given an integer array A of consisting of n elements, denote f of l comma r equals to max of that subarray. Determine if there exists a way to reorder A such that for every I, f of 1 comma I not equals to, in other words, split every point I. Okay, if you consider 0, if there is no 0, it fails. It always fails, right? So it's all about having 0 or not. But if there is a way to reorder them, okay. Okay, what about multiple zeros? I think even multiple zeros can be no. Multiple zeros and one, I think it's an. So, multiple zeros, 1 0, it's an S. Uh, Yeah, 1 0 it's an S because if it is containing 0, no 0, no. More than two zeros, okay. More than two zeros, okay. And there is a 1, there is no 1. If there is no 1, no 1, right? So 0 is what it decides. If you see, if once you cross the first 0, this will become 1 and also this will become 1. So it's no. Here, if there is a 1, you can always put all the ones in the front and then you can start putting zeros. Okay. Now, even if they have a 0, it will be 1. But these things will be 0, a non 1. And then 0, ones and then 0. So it's an S. So if is there a 1? Count of zeros is all we need. Okay. Count of zeros, E1 equals to 0. Okay. If C0 equals to 0, or okay, I'll just written as C out, no. Else if C0 equals to 1, C out S. Else C out, if there is 1, then it's S, else it's no. Right. Think about it one more time. If there is no 1, it's definitely impossible because after crossing first 0, you will have 1 1 on both sides. If there is a 1, you can keep ones in the front because the problem is can you rearrange them in some way or not, right? Now we'll go for C. Alice and Bob play a game on a binary string S of length and Alice moves first and the player takes turns. In one turn, a player chooses a sequence of indices such that the characters at these positions form a non-increasing sequence. Okay, they have to be non-increasing, means non-decreasing, non-increasing. The player then rearranges the characters at these positions to be sorted in non-decreasing order. So they'll reverse them almost. Okay, he will take some indices, he will reverse them. Formally, let the chosen characters consist of zeros and ones, so it's a binary string. The player moves characters at positions with a sequence of zeros followed by ones. Okay, move is valid if and only if it strictly modifies the string. If Alice wins, we want a valid first move too. What is when does a valid move exist? Zero valid move exist. Because you can choose those two things and then you can move them, right? If it is zeros and ones, Alice loses. Can Alice make it 0 and 1s? If it is, if the number can be, so what happens in one move is some zeros will come forward and some ones will go backward. And then the game repeats. You should return Alice's first move. Wait a minute. Can Alice always win? Uh, Consider this. Okay. Uh, take all the zeros. Take all the zeros that are here, and take all the ones before that. If the number of ones before this is equal to the zeros, then what happens? If you take zeros from here and if you take ones from here, those ones will come forward and then the zeros will come forward, come backward, right? So I think it's a bit about, if there exists an index where if you choose zeros from here and ones from here, you can move all the ones and it will fill these zeros perfectly. If that is possible, if that is possible, Alice will win. If this is possible, Alice can win because he can make it like that. So what happens when you move it like that? If it was a zero, because you have many ones here, you cannot do that. So you try to go here. So now you have many ones here. You can fill only these number of ones. Only one has been reduced, or one zero. If it was zero, you will have one more zero to fill that. So if you keep going, what is happening to, you want number of zeros on number of ones on left side to be less than or equals to number of zeros on right side. Okay, if you look, left ones minus right zeros, I think this is always possible. If it is greater than zero, you can keep going this side. If it was a zero, this is becoming plus one. If it was a one, this is becoming minus one, right? Left ones minus that. So you will reach a point where left ones will be equal to right ones. Then you can choose both of them, and then you can do that. You can do that. So this is possible. So we got our clear answer. Okay. So it's, if it's non-decreasing, Alice Bob will win, else Alice will win. Mm, non-dic equals to 0. Hmm. But I'm thinking, so when both of them become equal, then this value becomes 0. That should not happen that both of them are zeros, because then you cannot do a valid move, right? So in the other case, will both of them be non-zero? You have to just think about that. Okay, the first, let's say you're crossing few ones, and then you will have a 0, and then you will have 1. Okay, the first time you get a 0, there is some 0 before that. There is some 1 before that. So because of that, as you keep going this side, it remains non-zero for sure. The number of zeros on this side will remain non-zero because this will increase, right? So that's true. I don't know the variable name. Okay, now exist 1 0, let's say. One move is enough for allies to win, and that move, how do we determine that move? let's just get let's just get int val equals to 0. So we're starting from rightmost, all the ones are here. Now we are moving from behind, let's say. Okay, now we are moving from behind. We'll remove one character, and val is ones this side minus zeros this side. Okay, so val minus equals to cat c equals to s of I, let's say c equals to 1. Why? Because that c equals to 1 came from there to here, right? Val minus equals to c equals to 0. So it's just val minus minus. It's just val minus minus minus. Val equals to 0 for the first time. We have seen that there will be 0 on the right side. We have seen that. Take all the ones before that, take all the so we have moved I to this side, right? J less than I. If j less than I and s of I equals to 1, answer dot pushback of I plus 1. If j greater than or equals to I and s of j equals to 0, answer dot pushback of j plus 1. So this will be the indices. What's the issue of this? This will for sure exist. Okay, What happened, bro? So that's just the problem. It's a nice problem. One move game, right? Easy to guess. One move game. So there exists a way where you can have ones and zeros here. All the zeros here will be replaced by all the ones here. So it's perfect now. I took quite time on that. I hope it at least gets right correct answer. Because my luck hasn't been good right recently. Yeah, it is correct. Let's go for D1, D2. All easy problems. Should I go for E1, E2? We say that a bracket sequence A is better than a bracket sequence B. We say that a bracket sequence A is better than a bracket sequence B if one of the following holds. B is a prefix of A, but not A equals to B, but A not equals to B. So if B is smaller, or let I be the first position where AI not equals to BI, so it's not prefix. So first position where they both differ will exist. AI should be open and BI should be closed. Then A is better. So if this happens, let's consider this as smaller. So this says A is smaller. Else if it doesn't exist, okay, it should oh, okay, let's look at this as bigger. Let's look at this as bigger and this as smaller. Now A is bigger. Even here A is bigger. Right? What does it mean if A is bigger lexicographically? If A is bigger, it should either be bigger size, right? Or there should be a place where it is bigger. So yeah, it's very clear that what is better. You're given a regular bracket sequence of length S. So they're explaining what is a bracket sequence. They're explaining what's a regular bracket sequence. Among all non-empty subsequences T of S that are regular bracket sequences, find the maximum possible length of T such that T is better than S. If no such T exists, report it. We want a T which is better than S. And what is D2? We need to find the sum of scores over all subsequences of S. S is not necessarily a regular bracket sequence, and the constraints on N are lower. So it's a different problem altogether. Oh, I want charging. Bro, but